So again, our second model for the production possibilities frontier, this is the second model that we will talk about. The production possibilities frontier, PPF, usually we name it as PPF. It means that the maximum that we can produce goods and services for a certain economy. So the production possibilities frontier means what is the maximum possibility for a country to produce goods and services. And here, in this model, basically it's a graph that shows the combinations of two goods the economy can possibly produce given the available resources and the available technology. To provide a simple example, as we said, for example, if you are a student and ask you what is the maximum number of hours you can study, you will tell me 4 hours or 5 hours per day. This is your maximum. This is part of what this is, you can say, as the maximum productivity for you to learn and study for your education. Same thing with economy, because we have limited resources. Remember, economy is about limited resources. Here it's about what is, you should ask ourselves, what is the maximum production that can we produce as a country? So this is usually, we call it production possibilities frontier, which is usually we name it as PPF. So whenever we talk about PPF, we are talking about the maximum production for an economy. We have a simple example here. We have, for example, we provide, imagine that, or assume that we have economy, we produce computers and wheat, and we have one resource. Usually, in reality, we don't, but here we are talking about one resource, so we can make the model simple. It is measured in hours, as we measured studying in hours. Also here we measure labor in hours. The maximum number of hours we have for our economy, it is 50,000 labor hours per month. So this is our maximum number of hours that we can use to produce computers and wheat. Okay, the other assumption here for PPF example, to produce one computer, it requires 100 hours labor. It requires 100 hours labor. And to produce 1 ton of wheat, it requires 10 hours labor. For example, this is here in this table, we have employment of labor hours, and we have the production here. Here we have the production. So for example, we want here to use all our labor to produce computers. What is the maximum number we have here, number of hours? We have 50,000, right? As we said earlier in this slide. Remember, the maximum number of hours, we have 50,000 labor hours. We want to use, or we want to include all our labor to produce computers. So in this case, if we want to use all our labor to produce computers, how many computers can we produce? Very simple. 50,000 divided by how many? 100 hours. Because to produce one computer, we need 100 hours of labor to produce computers. So 50,000 divided by 100, how many computers can we produce per month? Remove zeros, with 2 zeros, we have 500. We have 500. So 50,000 over 100, we will have how much? We will have 500 computers. If you spend all your time on computers to produce computers, you don't have more hours to produce wheat. So here you have 0. But here in the second example, the second row, we assume that we will use 40,000 hours to produce computers. So how much left we have here to produce wheat?
10,000.
We have 10,000. So here 40,000 divided by 100, we have 400. 10,000 to produce 1 ton of wheat, we need 10 hours. So 10,000 divided by 10 hours, how much we have here? We have 1,000 ton to produce wheat. But if we want to produce half, if we want to produce, like we want to use half of our labor to produce computers and half of our labor to produce wheat. In this case, we will have 250 computers and we have 2,500 wheat. But if we want to produce more wheat, so in this case, we will use most of our labor to produce wheat. So in this case, we have 4,000 ton. How about we want to use all our labor to produce wheat? In this case, we have 5,000 ton and we have 0 computers. We have 0 computers. Why are we making these assumptions? We are making these assumptions to show you a graph in the next slide. Here is the graph. You see here? This is, we will put the table in a graph. So here, for example, point A. You see, this is point A. We have 500 computers. Here we have, in this axis, we have computers, and in the second one, we have wheat. So if you want to produce 500 computers, in this case, how much left do we have to produce wheat? We have nothing, so it is 0. So the point A will be here, right? If we want to produce 400 computers, so it will be 400 here, and it will be how much left? It will be 1,000 to produce wheat, 1,000. So what we are doing right now, we are just put all the numbers in a graph. We will put it in a graph. The next one, C, we want to produce 250 computers and 2,500. So this is 250 and this is 2,500. The next one, D, here we want to produce 4,000 tons of wheat and we have 100 computers. And the last one, E, we want to produce we want to use all our resources, which is labor. We want to use it to produce labor, and here, because we used all the labor, what's happened? We used all the labor here. So can we produce any computers? We can't. No. So as I told you, if you are a student and you have only 5 hours to study, for example, per day, and you spend all the 5 hours studying math, do you have more time to study for Arabic? You don't have time. So same thing here, because we have only 50,000 hours, we can only produce wheat and we cannot produce computers, because this is the maximum number of hours as a resource to produce wheat. As you notice here, all these points, we call them the PPF. We call this line is the PPF. What do you mean PPF? I mean, this is the maximum production we can produce in any point we have here on the line. So I will repeat this statement because it's very important. Any point we highlighted here, so here, let me put laser point. So any point you see it here on the line, we call it the PPF line, which means that this is the maximum production of the economy. This is the maximum production of the economy, because here we use the maximum number of hours of the labor. So if I say point A or B or C or even point here, if I make any point on the line, any point, whether here or here, this is the maximum production of the economy, whether computer or wheat. So here on the graph, find the point that represents 100 computers with 3,000 tons of wheat. Label it as F. So put the point as F. Okay? So I want you to give me a point where the country can produce 100 computers and 3,000 tons of wheat. Would it be possible for the economy to produce this combination of the two goods? Is it possible or it's not possible? Why or why not? Think about it. Also, find the point that represents 300 computers and 3,500 tons of wheat. Label it as point G. So would it be possible for the economy to produce this combination of the two goods? So let's have a look. For point F, they need how many? They need 100 computers and 3,000 tons. So here it is. What is it? So here 100 computers. Where is 100 computers? This is 100, right? Mm. Okay. And where is the 3,000 tons of wheat? This is the 3,000. So where is it? It should be here, right?
Yes.
What do we name it? We name it as point F, right? This is point F. Now, can we produce point F?
Yes.
Yes, we can. It is possible, but is it efficient? It is not efficient. Why it is not efficient? Because you can get more goods and services without sacrificing any of the other. So here, as you can see here, point F, we can produce it, but is it efficient for the economy? Or can we produce more? We can produce more. Remember, the best production for the economy is the blue color, is the blue slope. You see here, this is the best production. Any point under the slope, it is not the best production. We call it not efficient. We call it not efficient or inefficient. So as we said earlier, if you are a student, you can study 5 hours per day, but you only study 2 hours per day. Is it efficient for you?
No, we need more.
Yes, so in this case, it is not efficient for you to study only 2 hours. You can study 5 hours per day. So you are not very productive. You are not very productive student. So same thing here with the economy. If you produce less, in this case, your production is not very efficient. Of course, you can produce, but it's not very efficient. For the second question, point G, we need 300 computers and we need how much tons of wheat? We need 3,500. As you see here, G is above the slope. It's outside the slope. Is it possible to produce G?
No.
Because we need maybe about 65,000 hours of labor. This is not possible because the economy, we only have what, how much?
Just
we have 50,000. So because we have here limited resources, we cannot do it. Only for one exception. What is the exception? Maybe we can use better technology, right?
Yes.
So for example, let's say if we have a factory that produce, for example, goods, food, for example, instead of bringing more labor, maybe we can create or we can import robots or machines that can make the productivity more, because usually machines will help you to produce more, and machines is part of the technology. So in order to increase the productivity of any country, it is better to improve the technology of the economy. What we know so far about this graph, any point on the, as we said, any point on the slope from point A to point, they are possible. And they are what? We call them efficient. What do you mean by efficient? That we use all the resources. All resources are fully utilized or used. Points under the PPF, like point F, as we discussed earlier, it is possible, but it is what? It is not efficient. Some resources are underutilized. It means that we are not using all of our employment or employees. Maybe in this case, for example, we have workers that are unemployed, or the factories, we are not using the maximum number of labor, or the factories, in this case, they are not producing the best of their production. Here, points above the PPF, like point G, it is not possible. Why? Because it takes more resources. So what do we learn from this? Remember the opportunity cost concept we studied in the 10 principles of economics? The opportunity cost of any item is what must be given up to obtain that item. Which means that if we want something, we need to give up something else. If we, for example, if you spend, for example, you have 5 hours to study. If you spend 2 hours studying math, in this case, you are having less time to study Arabic language, right? In this case, you are giving up some of your time to study math instead of studying Arabic language. So this is the idea of opportunity cost. It's what you give up, So moving along a PPF involves shifting resources such as labor from the production of one good to the other. And this is the principle that we talked about earlier. Society faces a trade-off. What do you mean trade-off? Getting more of one good, such as, let's say, computer, it means requires sacrificing or decreasing the number of production of wheat, for example. So getting more of one good requires sacrificing some of the other. The slope of PPF tells you the opportunity cost of one good in terms of the other. Let me give you an example here. So here we have, this is a graph. So for example, to produce 5,000 tons of wheat, how much we need to give up? We need to give up how much? 500 computers, right? So to produce 5,000 tons of wheat, it means we are not producing any computers, which means we are giving up, we are losing 500 computers. And vice versa, the opposite way, if we want to produce 500 computers, how many tons are we giving up? How many tons we are giving up, or we are losing 5,000? We are losing 5,000. For example, the slope of a line equals the rise over the run. The amount the line rises when you move to the right by 1 unit. What does this mean? Very simple. I'll give you that. So here, for example, here you have, imagine that you are producing 5,000 tons of wheat. But now, how much do you produce computers? It is 0. So now we want to produce more computers. We want to produce, for example, 100 computers, right? So the point should be what? Goes to the right. Because we are producing more computers, what will happen to the production of wheat? It will go down, right? It will go down. How much it will go down? It will go down by 1,000. It will go down by 1,000. Why is it minus? Because it is what? It is decreasing. Minus because it is decreasing. While computers, it is increasing from 0 to 100. So this is 100 here. If we want to produce 100 computers, we need to give up, lose 1,000 tons of wheat. Okay? So here, whenever we want to produce one computer, we need to give up, or we need to lose 10 tons of wheat. We need to lose 10 tons of wheat. This is the idea of here of this mathematics. So for example, this evening you want to study economics. Your friends told you, let's go to the cinema. And you decided to go to the cinema. So what are you giving up? You are giving up the time that you should study for economics. So that's the idea. You should think with logic. If you cannot say, I will go to the cinema and at the same time I will study economics. You cannot do this because the number of hours is limited. The number of hours is limited. So here the opportunity cost of a computer, it means the opportunity cost to produce one computer, it means that you will lose 10 tons of wheat. So in other words, what you give up to produce one computer is 10 tons of wheat. It's 10 tons of wheat. This is the idea here.